Hey guys, welcome back. We're moving on to chapter 8.6. Here is some vocabulary where you can stop the video, look up definitions and examples on your online Teacher's Edition textbook. If that ain't enough, here's another set. And keep this in mind that an enhanced vocabulary just improves your ability to communicate and understand what it is you're learning, okay? Alright, next up I've got some notes for you. Okay, these are properties that you should already be aware of, so you can go and jot those down as a refresher if need be. And these here, okay, this is more to the point of the lesson. Alright, and what's going to be happening is let's look at this one right here. For the most part, you're going to have a going back and forth of where you have an exponent that's a fraction. Alright, if you have an exponent that's a fraction and you want to have this kind of notation, notice that the n becomes the index of the root, okay, or the radical, and the number on top becomes the exponent to that base. Alright, here's another explanation with not a 1 as a numerator but m, any other number besides, right? So if you have a raised to the m over n, we already said n becomes the index of the root. Okay, so if it was a 3, this would become a cube root. Okay, there a, and then m becomes the exponent. Right? So without the parentheses, this is what it would look like. Meaning you can also, instead of doing the nth root of a first and then taking that to the power of m, you can actually first take the base to the power of m and then take the nth root. Okay, so that's good to have in your notes. And this one simply reminds you that, okay, because we have looked at this in the past, that if you have any root of this product AB, it actually distributes. So that's good to know, have it in your notes in case you become iffy later. And same thing, if you have the nth root of this fraction, it also distributes to the numerator and the denominator. Okay? Alright. So this one's asking us to find all the real fourth roots of 16. Okay, as soon as you hear all, you want to definitely consider positive and negative. Okay, that's just a tip for you guys. Now what I'm going to do here on the side is I'm going to do the second root just for the heck of it, okay, because it's a little more familiar to us. So that means that the second root, okay, they're talking about some number squared should give me 16, right? Now, since it is the second root, right, to cancel out this square root, I'm going to do what? Let me do it right there. Okay. And again, we've been here before. So this is how I undo a square, is with the square root, right? But normally we haven't seen it too. It's typically invisible. But now that we're going to be working with these a lot, I'm going to make it clear that it's actually always there, even though a lot of times it's not included because it's used so often. Okay, so we know that this side becomes x. One thing I'm sure people have forgotten is that you really get a positive and a negative result. Alright, and the one thing you want to do here, just as a good habit for more difficult problems, is you want to reduce this value here, okay, the radicand, into its prime factors. So if you struggle with that, we can remind you how to use the calculator. Okay, so let's go to calculator, let's go menu, number, and we'll go factor. Okay, if I put in 16, hit enter, it'll give me all the prime factors. So this means it's 2 times 2 times 2 times 2. Right? So 2 times 2 times 2 times 2. So as you remember in the past, and that's why I'm doing this simple example, is you're supposed to circle every pair, because why? The index is a 2, so he pops out. Here's another pair, okay, so he pops out, and there's nobody left in the radicand, so I'm done. Therefore, my answer would be plus or minus 4. Now, many of you guys knew the answer already, but here's the algebra to back it up. Okay, with that said, let's go ahead and now address this problem. Again, find all. It's a nice little reminder that they're probably looking for positive and negative solutions. Okay, why? Because we are always prompted to kind of go positive only. So some number raised to the 4th power gives me 16. If you know the answer, good. Nonetheless, let's follow this process. So to solve for x, to find what that number is, okay, notice now that I'm going to have to take the 4th root of both sides. Okay, for the sole purpose it cancels out on this side. Okay, because it is also an even index, okay, like the 2 before us, we'll have a positive and negative solution. And the 16, we already checked on the calculator, breaks down to these prime factors. Right? Now in this case, hopefully you notice that I left off this index. It's very important. It's not a square root, it's a 4th root. So now I need not pairs, but groups of 4. Okay, so since I have 4 already, this, out of this group of 4, 1, 2 pops out of the radical. There's nothing left over, and that's my answer. X equals plus or minus 2. Right? Which means, in case you haven't forgotten, is that x can equal 2 and negative 2. Alright, moving on. This one says simplify the expression. Okay, I'll read it. For the 4th root of the quantity 256 z to the 16th, assume all variables are positive. Alright, last time they said all, now they just want us to focus on positive. Excuse me. So just to be on the safe side, I'm going to go ahead and go positive and negative, but they are indicating this. So just keep that in mind. Okay. All right. So in this case, what they're saying is we've got the 4th root 256 z 16. Okay. And I'll disregard that comment. We'll just focus on positive here. That way it matches with the types of problems you get on a test. So if I was to take the 4th root of this, okay, what's throwing me off is I was dealing with an x earlier, but this is kind of like in the middle of what I had already done. So let me go and kind of just break this down. So this, whoops, is equal to the 4th root, right? I need the prime factors for 256. So let's go menu, number, factor, and it's 256. Okay, so this is the number 2 multiplied times himself 8 times. So let's go ahead and do that. 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Alright. And what I'm going to do next, okay. Now at this point I could squeeze in the plus or minus, which is what I've been craving to do, but I'm going to stick with the program. And I'm looking for groups of 4. Alright. So I've got this, out of that pops out a 2. Out of this pops out another 2, and there's nothing left in the radical. If there was, I'd put it in here, but there isn't. Okay? So I'm left with a 4. Right? Now, if you notice that I left off the z's, let's go and address the z's. Okay, this one's a little more straightforward. This says z multiplied times itself 16 times. So let me see if I got room here. Okay, I'm going to kind of cheat. Z 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, wrote them all out just to encourage you guys to do the same thing. This index of 4 tells me to group them in 4s if they exist. So there's 1, 2, 3, and 4. Now out of each group of 4, only one z pops out, so he'll come out. Out of this group comes out another z, out of him, and out of him. Okay. Again, if there was, let's say, another z left over, then since he's not in a group of 4, he'd stay in the radical with a 4 index. Okay. But since that's not the case, I don't have to worry about anybody like that. So let me get rid of him since he wasn't there anyways. And then you go and put it back together, just like the 2 times 2 becomes 4. Z multiplied this many times becomes z raised to the 4th. And there's your answer. Again, I'd love to have that, but we're going to go with their assumption. And leave it like that. Okay? Alright, let's go and move on. This one says, write the expression 8 raised to the 5/3 in radical form and simplify. Round to the nearest whole number if necessary. Okay? Alright. I will tell you that for the most part, we're not going to have it necessary, so that's going to be a good thing. Okay? That'll be a good indication that you're doing things correctly. Alright. So if you compare this to your notes, this is going to be very consistent. Okay? So we have 8 to the 5/3. If you look at your notes, okay, you remember that this is the index of the root, and you've got the base 8 to the 5th. Alright, I don't have to, but just while we're on the topic of your notes, we could easily write this is 8 to the 5th, then take the cube root, or you can take what? The cube root of 8, and then raise that to the 5th power. The advantage of considering both options is you get to look at it and ask yourself, okay, which scenario looks easier to work with? Alright, 8 to the 5th looks like a big number. The cube root of 8 is not as big a number, so I'm going to go this route. Alright, I'll leave it up to you guys to attempt this one and see if you can get the same answer. Okay, so in this case, I'm going to go nice and slow, and because it is a cube root of 8, I'm going to break this into its factors, prime factors. Okay. Now, you may not feel you have to, but I would encourage you to do so. So you can kind of master the why behind a lot of your mental math. So anyways, we're going to go once again, menu, number, factor, numbers 8. Okay, and we got 2 times 2 times 2. I got 2 times 2 times 2. Right? And in case problems get difficult, this is a foundation that's very invaluable. Right? This index tells me to group them in 3s. Therefore, he would pop out. If there was another 2 in there, I'd have what? Square root of 2. But since there's not, only the 2 remains. Okay, this has been simplified, and I still got the 5 exponent. And now I just go and process that. So it's 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. Okay, and we are done with that one. Alright, next, write the expression 11th root of 10 to the 8th by using rational exponents. Alright, so what I'm going to recall is the bit of notes that should look something like this. Okay, where you have the nth root of, what were they using? A, I think, and then with exponent m. Alright, and according to your notes, that should tell you that A has the exponent what? M is the numerator and n is the denominator. Okay, so this is basically coming from notes, so I can follow them. So in this case, A is 10, M is 8, and N is 11. Okay, therefore I reset A is 10. Okay, M is 8, and N is 11. Alright, so they asked me to write the expression by using rational exponents, and here's my exponent, who happens to be a ratio, okay, or it happens to be rational. Alright, I'm looking to see if there's anything else that can be said about that. If so, I'll come back. And let's look at one final example. Simplify the expression 27 raised to the 3rd times 27 raised to the 2/3. Alright, so again, if you look at your notes, this is something similar to A raised to the M times A raised to the N. It's in quotations because it's from your notes. What does that say? It becomes AM plus N. Alright, so then in practice, a, the base is 27 raised to the 1/3 times 27 raised to the 2/3. So therefore, I can simplify because my base is what, 27. The bases must match, and according to this property, it tells me I can add the exponents. So I've got 1/3 plus 2/3. They do have the same denominator, so ultimately I get 27. 3/3. If you simplify 3/3, you get 27 to the first power, which is equal to 27. Guys, thanks for your time. I'll see you in class with questions, comments, and concerns. Appreciate you having you.